Hi everyone, welcome back, and in this video we will see why BJT is called as current control device, MOSFET is called as a voltage control device, IGBT is called as voltage control device, and SCR is called as charge control device. So here normally we are using the switch in our home for switch on the light, fan, etc. So just we are pressing the button, automatically the light will glow, and again if you are going to press the switch, what will happen? The supply voltage or supply current is cut off, and the particular lamp is going to switch off. So like that, in the electronic circuit we are using the semiconductor devices for switching operations. That is, if we want to get the output across the load, we are going to close the switch. If you are opening the switch, so there is no voltage or current is flowing from the source to the load. So in all the electronic circuits, we are using the electronic switch. So let us see what are the different types of semiconductor devices will act as the switch, and it gives its particular functioning. So these are all the commonly used semiconductor devices for switching purposes. That is diode and transistor. It is otherwise called as BJT, IGBT. So IGBT is nothing but it is insulated gate bipolar transistor, and MOSFET, SCR, triac. These are all the commonly used semiconductor devices for switching operations, and these are all the symbols used for the different semiconductor devices we have seen in the previous slide. That is, the diode is represented by using the symbol. This is called anode. The line will represent the cathode. And the BJT, there are two types of BJT. That is bipolar junction transistor, PNP transistor and NPN transistor. Here we are having the three terminals: base, collector, emitter. So the arrow mark that will represent the current flow direction. Right, the current is flowing from emitter to collector, so the arrow mark will be like this. Suppose in NPN transistor, they are having same three terminals, but their arrow mark direction is opposite to the previous one. That is, it represent the current is flowing from collector to emitter, and this is called IGBT. So here we are having three terminals: gate, collector, and emitter. And in MOSFET, again we are having the three terminals: gate, drain, and source. So here the N channel is arrow mark towards the particular line, but in the P channel MOSFET, the arrow mark is opposite to the N channel MOSFET. Here also we are having the same three terminals: gate, drain, and source. And in the SCR, it's like a diode. So a diode, we are having the anode and cathode. So like that, in the SCR also, the two terminals, anode and cathode. In addition to that, we are having the another one terminal called gate terminal. And in the triac is anti-parallel combination of SCR is called as the triac. Here there are two terminals: MT1, main terminal 1 and main terminal 2, and also gate. And before going to see that particular device is called voltage control or current control device, we should know some basic information about the different terminologies used for representing the semiconductor switches. So in that first terminology is called as the voltage blocking capability. Voltage blocking capability means what is the polarity of the voltage that a particular device will block, that will not allow that particular voltage. That is, it will block the particular polarity of the voltage. So that term is called as the voltage blocking capability. So normally it is represented by unipolar and bipolar. That is, unipolar device or bipolar device. Unipolar device means a particular semiconductor device will act as the switch. That switch blocks either positive voltage or negative voltage. So unipolar means the device only restrict the positive voltage or negative voltage. That is called unipolar. The example for unipolar devices or semiconductor switches are diode, bipolar junction transistor, MOSFET, and IGBT. And what is bipolar? The name itself we can easily understand. Understand that the switch that blocks both the positive voltage and the negative voltage, it blocks both the polarity of the voltage, so that it is called as the bipolar switch. The examples are SCR, diac, triac and GTO. So this is silicon control rectifier. Diac means diode operated in AC, triac means triode operated in AC, and GTO means gate turn off thyristor. And next terminology is the current allowing capability, that is unidirectional device or bidirectional device. It represents what is the polarity of the voltage that particular switch will allow, right? So that is called current allowing capability, the direction of current that particular switch will allow. That is called the unidirectional or bidirectional. The unidirectional means the switch that allows the current in only one direction, right? It allows from right to left or left to right, right? So it allows the current in only one direction, means that is called unidirectional device. Bidirectional device means that switch allows both the direction of current, positive current flow, negative current flow. Both the currents are allowed through the switch, so that is called bidirectional switch. The examples are the unidirectional switch is the diode, BJT, MOSFET, IGBT, SCR and GTO. Bidirectional switches are diac and triac. These two switches are only the bidirectional switches. The remaining all are unidirectional switches. Next one is the uncontrolled switch and controlled switch. So uncontrolled switch means the operator has no control over the switching action. That is the supply only responsible for controlling the switch. That is on and off of the switch is controlled by the supply only. An operator is not at all having any responsibility to switch on or switch off the device. That is, the operator has no control over the switch. Only the supply is having the control to on and off the switch. That is called uncontrolled device. And the example for uncontrolled switch is diode. Controlled switch means the operator has the control over the switching action. That is, whenever we need any current at the output side, at the time only we are going to close the switch. Otherwise, we are going to open the switch so that there is no current is flowing from the input to the output. So the operator has control. That is called controlled switch. The examples BJT, MOSFET, IGBT, SCR and triac. So there are three terminologies. That is what is unipolar or bipolar, the polarity, right? Polar means what? It is a polarity of voltage. So name itself we can represent the term polar. Polar means polarity of voltage. So the voltage blocking capability of the device is represented by unipolar bipolar, and the current allowing capability of the device is represented by directional, unidirectional or bidirectional. And depending upon the control action, right? Uncontrolled switch or controlled switch. And now let us see bipolar junction transistor. So what are the most commonly used switches in the electronic applications means BJT, MOSFET, IGBT, SCR. These four switches are used mostly in many applications. So now let us see some basic concepts about these four switches. So BJT means bipolar junction transistor. It is having the three terminals: base, collector and emitter. So the arrow mark outward direction represent it is a NPN transistor. If it is the towards this junction point, it is called as the PNP transistor. So normally BJT is called as the current control device, right? Current control device. There are mainly three types of control devices. That is current control device, voltage control device and charge control device. So BJT is normally called as the current controlled device. So this is the internal circuits of BJT: base, collector, emitter, and the base to emitter is biased by using some voltage source, and the output side also it is biased. So here, whenever we are giving the supply to the between the base and emitter terminal, automatically the base current is flowing through the base terminal. So without any base current, the output of the particular transistor is zero, right? So when we are getting the output, whenever we are applying the current IB, at the time only the output will be produced from the particular transistor. So that's why it is called the current control device. That is, the output is depends upon the input current, that is a base current. The base current is responsible for producing the output. Without this base current, the output is equal to 0. IB equal to 0 means automatically no base current, so there is no output. So the output of the transistor is mainly depends on the base current value. Okay, so that's why it is called the current control, right? The base current IB is responsible for getting the output, that is creating the output. So that's why it is called as the current control device. So how to remember this one? That is the BJT, the first letter is the B. So normally in the ABCD alphabet, after B we are getting the letter C. So we can easily remember BJT is the current control device. So these are all the important questions asked in many competitive exams. This BJT is the current control, voltage control, or charge control, like that. So just remember this trick, that is B. After the B we are getting the C. So the BJT is the current control device. Next one is the MOSFET. The expansion for the MOSFET is the metal oxide semiconductor field effect transistor. This is the symbol. So there are two types of MOSFET, N channel and P channel. Depending upon the arrow mark direction, it is the towards the junction, it is called N channel. It is away from, or the arrow mark is away from the junction, it is called as the P channel MOSFET. And here the MOSFET is called as the voltage control device. So why? So normally in that MOSFET we are having the terminals like drain, source and the gate. Now output of the MOSFET is only obtained by applying the input voltage, that is the voltage applied between the gate and source terminal. So if we need the output across the drain and the source, we want to apply the voltage between gate and source, right? If the gate to source voltage is 0, there is no output from the MOSFET, that is the between the terminal drain and the source, output is equal to 0. So the output of the MOSFET is obtained by applying the input voltage, that is the gate to source voltage. So the gate to source voltage is responsible for getting the output. The BJT input current is responsible for getting the output, but here the input voltage, right? The voltage, input voltage is what? The voltage between gate and source. It is responsible for producing the output across the drain and source terminal. So that's why it is called as a voltage control device. Output is depends upon the input voltage, so it is called voltage control device. So M is the MOSFET, first letter of the MOSFET M, and it is a voltage control. After M only we are getting the alphabet V. So that MOSFET is a voltage control device. Next one, IGBT, insulated gate bipolar transistor. So here normally the IGBT is the combination of MOSFET and BJT. Okay, so this is the MOSFET symbol. It is having three terminals, gate, drain and source. We know the transistor terminal, base, collector and emitter, right? So just take this gate terminal. So here the gate terminal is input side and the output side collector and emitter is here, right? So gate terminal of the MOSFET and the collector emitter terminal of the BJT are combined together. Finally the IGBT is obtained. Okay, so the combination of MOSFET and BJT is called as the IGBT, insulated gate bipolar transistor. So here the difference is we want to put two lines, but in the transistor just we are representing only one line, but in the insulated gate bipolar transistor or IGBT we want to put two lines because the gate is insulated. That's why we are putting the two lines. It is having the terminal gate, collector, emitter. Gate is the MOSFET terminal, collector and emitter are BJT, that is the transistor terminals. So again IGBT is called as the current control device, right? Sorry, voltage control device. The same concept as we have seen in that previous MOSFET concept, that is the output is obtained by applying the input across the gate and emitter terminal. That is the gate and the emitter voltage is responsible for getting the output. So that's why it is called as the voltage control device. So I is equal to V, that is we can also represent it as I is equal to V, that I is equal to V is nothing but after the I only we are getting the alphabet V. So that IGBT also voltage control device. Only we are taking the letter P after the alphabet I, that's why it is a voltage control device. That is, the input voltage is responsible for producing the output, so that it is called as the voltage control device. BJT, the input current is responsible, but after applying the input current only we are getting the output. But in the MOSFET and IGBT, whenever we are giving the input voltage, at the time only output voltage or current will be produced in the particular device, so that it is called the voltage control device. Next one, silicon control rectifier is called as the SCR. It's a charge controlled device. So normally this is the 4 layer in that N, that is SCR, and the P and N layer combined together we are getting the junction J1, and between these two layers again we are getting the J2 junction, and P and N layer between that J3 junction. The meeting point of two layers is called as the junction. So in the SCR concept, initially we want to forward bias the anode and cathode. Okay, so in that SCR there are 3 terminals: anode, cathode and gate. At the time of operation of SCR, initially we want to forward bias the anode and cathode. So after forward biasing the particular anode and cathode, we want to apply the gate voltage. Then only we are getting the output. Without a gate voltage, we can't get any output across the SCR. Okay, so the gate, whenever we are applying the gate and cathode voltage, the number of minority charge carrier in that particular layer will be increased. So if you are forward biasing the SCR, J1 is forward biased, J3 is forward biased, but J2 is under reverse bias condition. So this is forward bias, this is forward bias, but this is reverse bias. Here the reverse bias is open circuit. The current is not flowing from anode to cathode because it is reverse biased. It's an open circuit like that. So whenever the gate voltage is applied to the layer, what will happen? The minority charge carrier in that layers are increased, so that the J2 is also forward biased. So before applying the gate voltage, J1 forward bias, J3 forward bias condition, but J2 is reverse bias condition. It will act as an open circuit. So J1 and J3 are separated. No current is flowing from anode to cathode. Whenever the gate voltage is applied, at the time J2 is also forward biased. Initially it is a reverse bias condition. After applying the gate voltage, J2 is forward biased. So all the 3 junctions are forward biased. What will happen? It acts like a short circuit. So the charge carriers are flowing from anode to cathode. So it will act as the switch, that is the closed switch. So this is the operation. So the higher magnitude of the gate current pulse means lesser the time required to inject the charge current, right? That is, by controlling the amount of charge, we can control the turn on time. The turn on time is controlled by just we are applying the amount of gate voltage between the gate and cathode. So we are applying the high voltage, high current is flowing to the layer, the more number of charge carriers are created, so that particular SCR is quickly turned on. So depending upon the amount of charge carrier, the device will be operated and produces the output. That's why it is called the charge control device, right? So the gate voltage is responsible for creating more number of charge carriers in that SCR layer. So the charge carriers are producing the output. That's why it is called as the charge control device. So now let us see what are the different applications of these control switches. So the controlled switches are normally, already we have seen uncontrolled and controlled switch. In the controlled switch also again there are 2 subdivision: fully controlled switch and the semi-controlled switch. Fully controlled switch means both and on and off time are controlled by the operator. Semi-controlled means only we can control the on time, off time we cannot control. So that is called the semi-controlled switch. So BJT is a fully controlled switch. It is mainly used for high power and low frequency applications. And MOSFET is a fully controlled switch. Again, it is used for high frequency. BJT means high power application. MOSFET means high frequency application. And IGBT is a fully controlled switch. IGBT already said that it's a combination of BJT and MOSFET, so that it is used for both high frequency and high power. BJT high power, okay, and the MOSFET is a high frequency. IGBT is a combination of both, so that it is used for high frequency and high power applications. SCR is a semi-controlled switch. It is actually used for high power application, that is BJT also high power application, but as compared to SCR and BJT, SCR power rating is more as compared to BJT, right? That is, SCR is most commonly used for high power applications as compared to BJT. So compare all the devices, SCR is better because of its high power rating. Higher power rating, it is widely used in all the applications. SCR switches would be used. So these are all some basic information about BJT, MOSFET, IGBT and SCR. And apart from that, why it is called as a current control device and voltage control device, what is unipolar device, bipolar device, and directional bidirectional. Okay, these are the basic information about semiconductor devices used in the power electronics. Okay, thank you for watching. If you are new to this channel, kindly subscribe our channel AAA Encyclopedia, and if you like this video, kindly share it to your friends also.